Hey, welcome back to your favorite calculus class, you guys. We briefly introduced the chain rule before. I think we did that with Lagrange's function notation, where if you've got a composite function, it's f prime of it, and then the derivative of the quote inside, if you will. We're going to do a lot of textbooks will do that with u. U is like that g of x part. Use that inside. So you got f prime of u, and then you take the derivative of the inside. Here's another notation showing you the same thing. So like, let's for example look at this first one. We've got y equals -5 over x plus 3 cubed. Now this is a composite function, right? Like we could think about this if I let u be that inside, right? I'd have y equals -5 over u cubed. And we know how to take that derivative. Let's write it this way with our power rule. So we're like, oh yeah, I know how to take that derivative. Y prime would be the -5 stays there. Now I run the power rule, -3 u, and I go -3 minus 1 is -4. But I got to remember to take u prime, right? It's f prime of u, u prime. So now I take the derivative of u. Well, what's u? U is x plus 3. What's its derivative? Well, du dx is just a 1, right? It's just 1. So this just ends up being y prime equals 15 u to the -4. So y prime equals 15 over u to the 4th. But we got to make sure we put u back in. What was u? U is that x plus 3. So again, it's a composite function. So if you have something that's not just an x, right? Like in this case at x plus 3, you got a composite function. Then you got to take the derivative and then take the derivative of that, right? Derivative as is, so on. So here's another one. Here are, we have y, y equals 1 over 6x minus x over 6. So we got this mess to the 6. Now we know how to take the derivative of y equals x to the 6, right? So we're going to let u be the quote inside, if you will. So we have u to the 6. And so whenever we've got y equals f of u, and we take the derivative, if it's f prime of u and then u prime, right? So we're taking the derivative after we run the power rule on this one. So here are our u. Let's go ahead and go to the side and let's note our u here is 1 over 6x minus x over 6. In other words, 1/6x to the -1 minus 1/6 x. That's our u. Okay? So composite function again. We wrote it as a composite function. So we got y equals u to the 6th. Let's go ahead and take its derivative. So y prime would be 6u to the 5th. But don't forget u prime. So we got 6, y prime is 6. Our u is that, put our u in, and now it's to the 5th, and then u prime. So then I got to run the derivative of this over here. So what's our derivative here? Du dx would be 1/6 stays there. Run the power rule. -1 x to the -2 minus 1/6 derivative of x is just 1. Right? So our derivative of u is -1/6 x squared, right? X to the -2 minus 1/6. So go ahead and write that in. And there's our dy dx. I should mention you notice that 6 right there. If I distribute that into here, cancel that and that. So really a little better cleanup on this would be 5th And then negative 1 over x squared minus 1. That would be the best simplification there. Let's keep going here. We've got another composite function. Instead of cosecant of x, I have cosecant of cotangent, right? So that's my u. My u is that cotangent. So if I let u be cotangent, what I have is the cosecant of u. And then I just look up the cosecant of u. All right, remember, we're doing y prime would be f prime at u, u prime, right? So let's go ahead, let's take its derivative. And then I look up and I say, oh, the derivative of cosecant is negative cosecant cotangent, right? But again, don't forget, now I got to go u prime on this, right? So let's go over here, let's take u prime. So u prime du, this time it's in terms of theta, du d theta, so u prime would be the derivative of the cotangent is negative sine. So that's what's going to go in right there, right? So y prime equals negative cosecant u, and we need to put our u back in, right? Our u is cotangent. Cotangent of the cotangent, there's our u again in. And then u prime, what's our u prime? Negative sine. Can't square. Guys, my apologies, I just realized that's wrong. Derivative of the cotangent negative cosecant squared. Sorry about that. Cosecant squared, my goodness. Cosecant, bless you, squared. There we go. Now I got a negative times a negative, so that'll be positive. So y prime just ends up being cosecant of u, which is our cotangent. Cotangent of u, and the derivative of u, which was the derivative of the cotangent, which was cosecant squared. On this next one, you've got y equals 9x minus 7 to the fourth, and the ideal is to not have to always write the u every time. I know you got y equals u to the fourth, right? But hopefully you start just seeing, oh, that's a composite function, so I'm going to run the power rule. There's my u on the inside, and now it's to the third, but I got to take u prime. So what's the derivative of 9x minus 7? It's just times 9. Minus 0, right? And so you start getting kind of quicker at taking your derivative. So your dy dx, multiply the 4 and the 9, you get 36, 9x minus 7 to the third. All right, again, apply the rule. Here you've got y equals 3x squared minus 4x plus 6. It's all to the 1/2. Right, so the u is all that stuff on the inside. So your y prime would be, I'm gonna run the power rule. So I've got a half, I've got that u stuff on the inside. Now to the 1/2 minus 1, so that's a negative a half. But again, I got to take the derivative of u, that stuff on the inside, which is 6x minus 4. And then I go ahead and multiply the half times that 6x minus 4, both of those. And that'll give me a 3x minus 2. And then that u stuff is all to the negative a half. So that's down below to a 1/2 power. In other words, it's a square root. Right? So there's your dy dx on this one. All right, here's some more. This is a great you try problem. If you want to pause the video, go ahead and try this. Hopefully you noticed that your sine of x is the u. And so when you run dy dx, is 5u is now to the fourth derivative of the sine, which is the cosine, right? So you have 5 sine, let's go ahead and rewrite that, dy dx is 5 sine of x to the fourth power cosine of x. Next one here, we've got y equals x to the 7th minus 5x to the 4th. This is all to the 1/6. I want to write that in exponential notation instead of radical notation. Again, another great you try problem if you want to pause this and give this one a shot. Well, hopefully you recognize that this is your u on the inside right there. That's your u. So you've got your power rule going on. So you got 1/6 goes in front. The u stuff is now to the 1/6 minus 1. So 1/6 minus 6/6 is a negative 5/6, right? And then we got to take the derivative of that inside right there. So we've got 7x to the 6 minus 20x to the 3rd. Now you do want to rewrite this in a pretty format with no negative exponents, right? So you got your dy dx equals, you get this 7x to the 6 minus 20x to the 3rd. You get your 6 on the bottom, and then this x to the 7th minus 5x to the 4th is then to a positive 5/6 down there, right? Because remember, a to the negative m is 1 over a to the m, right? All right, let's go ahead and look at this next one here. We've got y equals x times the square root of 4 plus x squared. In other words, 4 plus x squared to the 1/2. So I've got a product here. I'm going to go ahead and use my product rule. So dy dx is derivative of the first. The derivative of that x is 1 times the second. So I've got, here's the second one. I just leave it alone. Plus the first. Now I leave the x alone. But then I'm running the derivative of the second one right here. So I've got to run power rule. 1/2 minus 1 is negative 1/2. But then I've got a chain rule on this. So I got to take the derivative of the inside here, which is 0 plus 2x. So just a 2x right there. Okay. And then I'll just clean this up. So y prime equals, I got square root of 4 plus x squared. Notice these 2's right here cancel. And I've got x, and then 4 plus x squared to the negative 1/2. That's 4 plus x squared to the positive 1/2 on the bottom. All right. I am going to get a common denominator here. This is over 1, so I got to give this a square root of 4 plus x squared. Give this a square root of 4 plus x squared. And so my y prime here ends up being square root of 4 plus x squared times the square root of 4 plus x squared. Undoes that radical. So it just leaves me at 4 plus x squared. Then we got a plus x, and this is all over this common denominator. Square root of 4 plus x squared. So 4 plus x squared. Oops, I didn't carry that dang x squared right here. That should have been x squared. Sorry about that. So we got 4 plus x squared plus an x squared. So I got 4 plus 2x squared. This is my numerator over that square root of 4 plus x squared. Or, frankly, I kind of like 2x squared plus 4. Let's put the, I'll write it with the degree, highest degree first there. So here we've got the quotient rule. So dy dx will be derivative of the top. So let me go ahead and take the derivative of the top. I got 4 x plus 1 is now to the 3rd. But don't forget the derivative of 6x plus 1, which is 6. There's the derivative of the top times the bottom. So I leave the bottom alone. Minus, with the quotient rule, the top. And then I go derivative of the bottom. So I got 5. 2x plus 1 to the 4th. Derivative of 2x plus 1 is just 2. And then this is all over the bottom squared. And we just got to clean this mess up. All right. So I got 24, I got a 6x plus 1 to the 3rd, I got a 2x plus 1 to the 5th, I got a minus 10, I've got a 6x plus 1 to the 4th, I've got a 2x plus 1 to the 4th, and then over 2x plus 1 to the 10th. So what I'm going to do is I'm going to take out front, let's see, I could take a 2 out of each of those terms on the top. I can take out 6x plus 1. I could take out 3 of those max. And I could take out 4 of those 2x plus 1. So then I'd be left with, if I take 24 divided by 2, I got 12. I got one of these 2x plus 1s left, minus 5, and then one of these 6x plus 1s left. And then if you notice 2x plus 1 to the 4th, 2x plus 1 to the 10th, that'll leave me with 2x plus 1, 6 of those on the bottom there. And I'm also going to go ahead and clean this up and combine like terms. So let's see what we have now. So y prime equals 2. I get a 6x plus 1 to the 3rd. I've got 24x plus 12 minus 30x minus 5 all over this 2x plus 1 to the 6th. So y prime ends up being 2, 6x plus 1 to the 3rd, 24x minus 30x, I got a negative 6x, 12 minus 5, I got plus 7. This is all over 2x plus 1 to the 6th. And you know what? I'm going to take a negative out of that right there and make that a negative 2 in front instead. So my y prime, make that a negative 2, which will change your signs of that negative 6x plus 7. So I'll have 6x minus 7. I just prefer having a positive coefficient of that 6x term there. And that's all over 2x plus 1 to the 6th. All right, here hopefully you notice that u is again on the inside. That's our u. So when we run that derivative of the u for this chain rule, we're going to have to run the quotient rule for that, right? But let's go ahead and use the power rule first. So let's take h prime of t. I got the 2 now is in front, and then my u stays the same for a minute here. Now it's to the 2 minus 1, so to the 1 power. I don't need to write a 1 there. But then we're going to go ahead and take the derivative of u, which means I got to use my my quotient rule. So I got derivative of the top times the bottom, minus the top, derivative of the bottom, which is 3t squared plus 0, all over bottom squared. And then I just want to clean that up. So I've got 2t squared, and then derivative of, I'm going to go ahead and take, distribute those there. So I got 2t to the 4th plus 4t squared minus 3t to the 4th all over t cubed plus 2 squared. And then over here I did have a t cubed plus 2. So h prime of t, h prime of t is 2t squared. And then notice I got 2t to the 4th minus 3t to the 4th, so I got a negative 1t to the 4th, right? And I've got 2t, oops, that was a, sorry about that. 2t times 2 is a 4t there, sorry about that. So inside I've got is minus t to the 4th all over this t cubed plus 2. And that's now to the 3rd. And I could take another t out of each of these if you wanted as well. So h prime of t would be 2t to the 3rd, and I have 4 minus t cubed all over t cubed plus 2 to the 3rd. All right, here we've got, sometimes you're going to have to use the chain rule more than once. So here you've got an f of g of h of x situation where your h of x is the 9, or I'll call it h of theta. Well, we'll just use x from it. Is that 9x or 9 theta? the g of x is the cosine. And then the f of x is the sine. All right, so the g is going into f, and the h is going into g, right? So we got a composite of a composite here. So when you take its derivative, it'll be the derivative g prime, h, and then you got to go h prime. So here we'll have, let's go ahead and run it, f prime. So what we'll do is we'll say, okay, what's the derivative of the sine? Cosine of that. Now we're going to take the derivative of the cosine. And I know the derivative of the cosine is negative sine of that. But don't forget, I don't just have theta in there, I got 9 theta. So I got to take the derivative of the inside again, right? Derivative of 9 theta is 9. And then we just clean it all up. I've got a negative and a 9. I'm going to go ahead and put that out front. So it'll be negative 9 cosine of the cosine of 9 theta times sine of 9 theta. And I'm all done. So chain rule applied more than one time because I got a composite of a composite. So here we've got another composite of a composite, if you will, right? So we're going to go ahead, we're going to take the derivative of the cosine. So I know the derivative of cosine is negative sine of stuff, right? So I'm going to leave that the same. And then I'm going to take the derivative of the red. So I'm going to go power rule, 3/4, 4x plus 7 to the 3/4 minus 1, which is negative 1/4. But notice I don't just have an x on the inside, so I got to still run the derivative of 4x plus 7, which is 4. And then I just got to clean all this mess up. Notice 3/4 times 4, so the 4's will cancel there. And so I've got my dy dx ends up being, I got a negative 3. I got sine of this 4x plus 7 to the 3/4. And then I've got that 4x plus 7 to the negative 1/4. So that's going to go down and become 4x plus 7 to the positive 1/4. And that's where I'm going to stop right there. I've got all positive exponents on that. All right, here we've got y being 2's in front, so the constant's going to stay there when we take this derivative. So here we go. Y prime, or dy dx, 2 stays there. Let's run the power rule. So I got cotangent squared. So I got 2 cotangent pi x plus 2. Now that's to the first power, cotangent pi x plus 2. And then we'll take the derivative of cotangent. All right, so this is to the first power. Now what's the derivative of the cotangent? And I look it up and I say, okay, that's negative cosecant squared is the derivative of the cotangent. But then I got to take the derivative of that pi x plus 2, which is just a pi. Okay, so let's go ahead and I'm also going to erase this to the first power so you don't think that's a derivative right there. So let me just erase that. So we got dy dx ends up being, I got a negative 4 pi. I've got cotangent of that pi x plus 2, and then cosecant squared pi x plus 2. That's my derivative. Okay. Here we've got y being e to the negative x squared. And if you remember, anytime you got a to the x, the derivative is the ln of a times a to the x, right? So we're going to go ahead and run that. So the derivative is ln of e to the negative x squared. But the problem here is I don't just have an x up there. I got to take the derivative of that. I got a composite function, so the derivative of negative x squared is negative 2x to the 1 power, all right? And of course we know ln of e to the 1 is just 1, right? This just ends up being 1. So our y prime ends up being negative 2x e to the negative x squared. Let me rewrite that as negative 2x over e to the positive x squared. Here we've got our dy dx. I'm going to run power rule first, so 6 e to the sine of x over 2. Now it's to the 5th power. Now I got to run the derivative of the inside there, so that'd be ln e to the sine x over 2. Right, so there's the derivative of the inside. Now I got to run the derivative of the sine, which is cosine that x over 2. And then lastly, one more time, derivative of that x over 2 is just derivative of 1/2 x is just a 1/2. Okay, and so now we're just going to clean all this up. And remember, ln of e this is just 1, right there. And so I got 6 over 2, which is 3. So dy dx equals 3. I'm going to go ahead and write my cosine of that x over 2 next, and then I got the e to the sine of x over 2 here. E to the sine x over 2. That's to the 5th. I've got another one of these e to the sine x over 2 as well. So remember the rule, a to the m, a to the n, a to the m plus n, right? So I've got 6 of those. E to the sine x over 2 to the 6 of those. That's probably a little better notation. It's, a times b is b times a. I kind of like that 6 in front a little bit more. All right, last one here. We're going to go ahead and take derivative. Derivative of the sine is just the cosine of that stuff. And now we're going to have to use the quotient rule. So we got derivative of the top times the bottom minus top. Derivative of the bottom. Now remember that theta minus 4 is to the 1/2. So that'll be 1/2 theta minus 4 to the negative 1/2. 1/2 minus 1. And then the derivative of theta is just a 1 times 1. Right? All over bottom squared. So that'll undo the radical, of course. So we got square root of theta minus 4 minus theta over 2 square root of theta minus 4. This is all over. I'm actually going to leave that right there for a minute. Okay. I'm going to get a common denominator in this numerator. So right now that's over 1. So I'm going to multiply by 2 square root of theta minus 4 to get a common denominator. 2 square root of theta minus 4. And so I have y prime being cosine of this times 2 square root of theta minus 4 times another square root of theta minus 4 is just a regular old theta minus 4, right? It undoes the radical. Minus theta. This is all over 2 square root of theta minus 4. That's our common denominator. And then that's all over square root of theta minus 4 squared, which is just theta minus 4 with a 1 power, right? Go ahead and this is over 1, so I'm going to multiply by the reciprocal. Okay, so I'll have y prime equals cosine theta over square root of theta minus 4. And I've got 2 theta minus 8 minus another theta, so that's just theta minus 8 all over 2. I've got square root of theta minus 4. And I've got a theta minus 4 to the 1 power. So 1 plus 1/2 is 3/2. So I've got cosine of this stuff. I've got theta minus 8 over 2, theta minus 4, 1 plus 1/2 is 3/2. And I'll go ahead and leave it right there. Thanks so much for watching. Taking notes on chain rules. See you next time.